Continuing on with Chapter 11 over rational equations and functions today, we're going to be adding and subtracting rational expressions. The bottom line here is that when you very first learned how to add fractions, you learned that you had to have a common denominator. The same thing applies today. So here we're being asked to add these two fractions. Do we have a common denominator? Yes, we do, y plus 5. So when that's the case, the denominator just stays the same, and we add the numerator. So 3y plus 4 over y plus 5. On the top, we don't have any common terms or like terms, so we're done. That's our answer, 3y plus 4 over y plus 5. How about this? We're being asked to subtract these two fractions. We do have a common denominator, 2n, so we'll keep that denominator. On the top, we'll do n minus 3 over 2n. The only difference here is that we have negative 3 and negative 3 are like terms. We can make that negative 6. So we end up with n minus 6 over 2n. There's nothing that can be simplified there. So that's our answer, n minus 6 over 2n. This looks much more complicated, but there's really not all that much to it because we do have a common denominator, 2x squared minus 7x plus 5. So on the top we'll go 1 minus x plus 3x minus 3 over 2x squared minus 7x plus 5. Then we'll simplify the top. Negative x plus 3x is 2x, and 1 minus 3x is negative 2. Now, one thing I'm noticing now that I look at this a little bit more closely is that this top expression can be easily factored. The bottom expression might be able to be factored as well, and maybe there's some more simplifying that we can do here like we did in the last section. So let's try and factor 2x squared minus 7x plus 5. The lead coefficient is not 1. And it's not a special product polynomial, so we're going to have to use the AC method. So d times e should equal a times c. 2 times 5 is 10. And d plus e should equal b, and b is negative 7. So from that, we can determine our values of d and e to be negative 5 and negative 2. Negative 5 times negative 2 is 10. Negative 5 plus negative 2 is negative 7. Here's this expression that we use in the AC method. A is 2, D is negative 5, E is negative 2, and C is 5. I can take an x out of the first expression and a negative 1 out of the second expression. So 2x minus 5 and x minus 1 is the factorization of 2x squared minus 7x minus 5 plus 5. So let's factor the top, taking out the 2. Factor the bottom, we just did that. And it's a good thing we did that because x minus 1s will cancel out and leave us with our answer, which is 2 over 2x minus 5. So a little bit of an added step there. I thought it was going to be a little bit easier than that, but we needed to factor the denominator and simplify. All right, so finally we get to one where we don't have a common denominator. So we have to think, what's the least common multiple between 3x cubed and 6x? The least common multiple would be 6x cubed. So that's going to be our new denominator. So we want to make the denominator of each one of these fractions 6x cubed. So the first one, we already have the x cubed. How do we turn the 3 into a 6? Multiply it by 2. Whatever you do to the denominator, you have to do to the numerator. Over here, how do we make this 6x into 6x cubed? We've already got the 6. If we multiply the x by x squared, then we'll get 6x cubed. Whatever you do the denominator, you have to do the numerator. So we'll have 10 plus 7x squared on the top. And the only thing I'm going to change on that is I'm going to write that in standard form. This top numerator can't be simplified or factored at all. So that's our answer. We're done. So you got to get a common denominator, and then you can go from there. All right. Again, we do not have a common denominator. So what's the least common multiple of x plus 1 and 1? Some people might make the mistake that they think, oh, I'll just add 1 to this. But it's not about addition and subtraction. It's about multiplication. So the least common multiple between x plus 1 and x is x times x plus 1. So that's what we want our denominator to be. So how can we get the x added onto this x plus 1? We'll multiply by x over x. And how can we get the x plus 1 down here? We'll multiply by x plus 1 over x plus 1. So x times x plus 1 is x times x plus 1. X times x plus 1 is x times x plus 1. On the top, x times 2x squared is 2x cubed. On the bottom, we're going to subtract, remember it's subtraction, x minus 1 times x plus 1. These are two binomials and we're multiplying them. By the way, sum and difference pattern. So this should be, if we have a minus b times a plus b, we should get a squared minus b squared. So how about x squared minus 1? Let's distribute that negative sign. The bottom, we're not going to bother simplifying that. We'll just leave it in factored form in the denominator. And there's nothing that we can do beyond that. That's our answer. Okay, so why don't you try this one? Go ahead and press pause, and when you're all done, press play, and my answer will be waiting. A little hint for you, make sure you simplify completely after you add the numerators. Okay, so we do have a common denominator, so I'm just going to add up the numerators here, 3n, and then we've got the 1's canceling out. On the bottom, I'm going to factor out the greatest common factor. So 3n squared and 3n are both divisible by 3n, so I'll factor out that 3n. Then we can see the 3n's can be canceled out, so 1 over n plus 1. All right, try this one. Remember to get a common denominator. Press pause, and when you're ready, press play. Okay, so I want my common denominator to be 2y plus 1 times y plus 1. All right, so I'll multiply this by y plus 1 over y plus 1. And I'll multiply the second fraction by 2y plus 1 over 2y plus 1. Okay. So y plus 1 times 3y. We use distributive property to simplify. That would be 3y times y would be 3y squared, and 3y times 1 would be 3y. We're going to subtract, and we've got a binomial times a binomial over here. Y times 2y is 2y squared. And we've got the middle term would be y times 1 and 3 times 2y. So 1y plus 6y is 7y. And then lastly, 3 times 1 is 3. I'm going to distribute that negative sign. So it'll be negative 2y squared, negative 7y, and negative 3. And then I'm going to simplify the top by combining like terms. So we'll have y squared minus 4y minus 3 all over 2y plus 1 times y plus 1. And one thing to consider here is maybe this top can be factored, and maybe then you'll be able to simplify more. but y squared minus 4y minus 3 is not factorable. There are no factors of negative 3 that add up to negative 4. So this cannot be simplified any more than that. Okay, that's it for section 11.6. I would highly recommend that you read section 11.6, which starts on page 676 of your textbook, and come in with your questions and complete a note sheet tomorrow, and we'll do some more practice. Have a good night.